In this video, I'm going to show you how to use prop.test to perform a left-tailed test that compares two population proportions. To do that, I'm going to need a set of hypotheses, and they're going to be right here. First one's going to be that the proportion of successes in one population is the same as the proportion of successes in the other. The alternative is going to be the proportion of successes in the first population is less than the proportion of successes in the second population. And now to perform this test, I would need to decide upon a significance level, a probability of a type 1 error. In this case, we're going to just use 0.03. And then I need some kind of a rule for rejecting my null hypothesis. So we'll use this rule that says we'll reject if our p-value is smaller than our significance level, that alpha number we decided upon. Then I need to go out and collect some samples, and I need to do it in a very particular way. I need to go to both populations and make sure I get a simple random sample from each of them. And then I'd have to look at my samples and make sure that the sample sizes are big enough. The way you're going to do that is make sure you have at least 10 successes and 10 failures in both populations. And now if we look up here in my made up data, I do have at least 10 successes and 10 failures. So I'm going to go ahead and pretend like we're doing something legit here. Since this is made up, it's not really legit, but just so you can see how the computations work. So the way I'd go about performing this test is I'd use this prop.test function, and then I'd have to tell it the number of successes I have. And since I have two populations, I have to give it both of those values. So I had 22 successes in the first population. I had 27 successes in the second. Then I'd have to tell it my sample size from each population. And since I have two of them, I have to tell them both. We'll put it in vector form. So I have to say I had 51 successes from the first and 39 successes from the second. And then I come along, and what I need to tell it is just what my alternative is. Okay, so we look at my alternative hypothesis, and we say that our P1 is less than P2, so I can use a less option there. So I just type in alternative, and I say that that is less. All right. And so then I can go ahead and perform my test, or at least have the computations performed for me. And then I look up here and I notice that there's a two-sample test for equality of proportions. Then I'll see my data values showing up. Just want to make sure they're correct. I want to make sure my alternative is correct there. And then what I'm looking for here is my p-value. And the p-value on this is 0.01224. And now what I want to do is go back and compare that to my significance level. And I'll notice that that is indeed smaller. So this would be a case if this was actually real data, where I'd want to think, well, I have evidence to believe that my null hypothesis is wrong, so I'm going to reject that null hypothesis there. Anyway, so that's how you can use the prop.test to perform some computations to do a left-tailed test that compares two population proportions of success.